All right. So there's two ways that we use angles with directions. One of them I'm going to work in red, and that is this. North is 0, and we measure this way. So how many degrees would this be from 0 to east? 90. And then what would this be? 180. And then what would this be? 270. And then 360, right? So one of the ways we use to measure, and you guys have seen this or heard this when you watch movies, he's running, the sub is at a bearing of 218 degrees. What that means is this is your starting point, and 218 degrees would be over here. Because you start at 0 and you count this way, 218 degrees. Is everybody cool with that? That's one of the ways we use to measure direction. So if I told you the buried treasure is at a heading of 297 degrees, where would you walk if this is starting point? What direction would you go? Up and right, down and left, or up and left? Up and left, because 292 would be out in here. Does everybody understand that? Everybody's cool with that one? That's the easy one. Nobody has any trouble with that one. Everyone's good? Okay. The other way we use these, and this one is a little complex, so please pay attention. Because what we're going to use for this is similar, but not quite the same. The other way we measure direction, or we use to describe directions, is this. E, then a degree. Oh, sorry, not E. A direction, then a degree, then a direction. So it would look something like this. North 45, not 45, I don't want to do 45. North 49 east. And what this means is this is where you start, and this is your adjustment. So what that says is you start walking north, but you adjust 49 degrees to the east. So where is east? If I am walking north, here I am, I want to walk this direction. How that works, if I walk north, I'd go straight up, yes? But I am not walking north. I am walking where? 49 degrees to the east. So assume you guys are north of me. Am I turning to the right or the left? To the right. How far? 49 degrees. So the direction I am actually walking, if my computer ever works again, which of course it won't.
I think it's getting worse.
It is getting worse, actually. And I need to, now it erased the wrong thing. That's impressive. It's not actually erasing the blue line that I would like to erase, as you can see me going over it a million times. But it did erase the black line that I wanted to keep. Oh, there it goes. So I'm not really walking that way. I'm actually walking over here. Yes? Now here's how it works for trig. If I adjusted 49 degrees that way, do I have a triangle yet?
Yeah.
Not yet, but I can get a triangle by either putting this one in here or this one up here. Does everybody understand? Where would the 49 degrees be? It would be here. And then what would that make this side? The whole thing is what? No, the whole angle from north to east is what? 90. If this is 49 of it, what's this? 41. And now I have two triangles with which I could do trig. Does everybody understand that? Okay, so if I told you to walk west 18N, where would that go? So I would start out going west. That's the first leg of the triangle, yes?
Yeah.
If I was going to do trig. And how far would I go up or down on this drawing? Up, how far? 18 degrees. So this would be 18. And this would be the line I was walking. Does everybody understand that?
Yeah.
So if I wanted to do trig with it, I'd have 18, an opposite and an adjacent and a hypotenuse. Or I could do 72 with an and use this side of the triangles. Everybody cool with that? Okay, I apologize that I didn't go over this when I should have gone over it. But it's not that complicated. It's just trig and subtracting from 90 degrees, yes? Everybody's good? So when you have a direction question, it's always a good idea to draw yourself the northeast, southwest. And then just depending on the question. If the question is in degrees up to 300, then it's just a circle. If it's in this form, then you got to be aware of where you're starting and where you're adjusting. Cool? Yep. All right. Now, I left you with page 70 and 71 because we went over all of up to 70 and 71. There it is. There's the mountain question. So I left you guys here. Any questions? Robert? Okay. Any questions from 70 or 71? Everybody was able to work them out? Who bothered to do it? Lovely, that makes my life easy. In which case, you guys should then be looking at, on your books, a page entitled Test Review. No, the page that says Test Review. It's page 72. On page 72, I would recommend that you use that page right now to write down a one-page reference for studying purposes. Okay? Remember, all you need to know for trig is two things, yes? One thing you need to know for trig is Sohcahtoa. Do you actually have to have it memorized? No, but you do need to be aware of how to use it. So I know you've drawn this triangle a million times already, but we'll put it here in one place. Okay? There is a black theta, yes?
Yeah.
Black theta means what is this side? Opposite, adjacent, or hypotenuse? Opposite. And we are going to name that side A. If that side is little a, what is this angle?
Big A.
Big A. Excellent. And if that is opposite to black theta, then what is this? Adjacent. And we are going to name him little b, which makes this angle what? Big B. Excellent. And there's our 90. If that is 90, what does that make this guy? Hypotenuse. Why did I draw the hypotenuse in green, do you think, when I put the other two in black? Why did I draw the hypotenuse in green? You know I use the colors to highlight things to you guys. Why is the hypotenuse green when the other two are black? maybe this will help. I'm going to use blue to write this theta. If this is a blue theta, this is theta now, then what's this?
Opposite.
Opposite in blue. What is this then?
Adjacent.
Adjacent in blue. The hypotenuse is still green. Why? Carlin.
Because no matter what you look at it from, the hypotenuse doesn't change.
Absolutely right. The hypotenuse will never change. Okay? It is always the hypotenuse. The other two change depending on what angle you are using. Right?
Yeah.
So again, we've done this a million times, but some of you still have trouble with it. What is the sine of black theta? Do not say it out loud. Just write it down with the little red letters. And then, of course, what is the cos of black theta? Use the little red letters. And what is the tan of black theta? Use the little red letters. Then, of course, you'll do the same thing with the blue theta. Awesome. High quality. Now, somebody who isn't somebody that answers my questions all the time, please tell me what any one of those 6 is. I don't care which one you tell me. I don't want to put you on the spot. You tell me what one of those 6 are. Anybody except one of the people that usually answers my questions. Daniel.
Sin theta equals A over C.
Which? Black or blue?
Black.
Black, sine theta is little a over c. Absolutely correct. What else is little a over c? The other side. Which one? Sine, cos, or tan? Nice, Robert. Well done. What else? Somebody else. I really hope I don't have to open this up to the whole crew, but obviously I need to. Somebody else, tell me one of the remaining 4. It's always rewarding to see how well my teaching has gone over. It makes my heart swell. Yes, obviously, Carlin, you will have to say it now.
Cos of black theta is B over C.
B over C. And what else is B over C?
A blue theta?
Which blue theta?
Sine.
Sine of blue theta is B over C. And tan of black theta?
Is
A over B. And tan of blue theta?
A over B.
No.
Or no, B over
B over A. Now, for some reason, almost all of you can do this. On that first day, everyone's like, oh yeah, okay, I got that. So, yeah. But then I put numbers in. And for some strange reason, you got in trouble. If I told you A was 4, what would you put for every letter A you see here? 4. If I told you B was 3, what would you put for every B you saw? 3. If I told you C was 5, what would you put for every C? 5. So you could do this, yes? Excellent. The next thing you have to be able to do is basic algebra. And to do that, I ask you this. How would you solve 10 equals x over 5? What would you do to tell me what that answer is? You all know what that answer is. What is it? You do the opposite to what you see. What do you see? You see x divided by 5. So you must do multiply by 5. Cancel. 50 equals x. All of you can do that. You've all been able to do that since the 7th grade. The only thing that changes is instead of this being 10, it's now sine of 72 equals x over 5. So you just do the exact same thing. And yet, even though your teachers have been telling you forever that math's a pattern and it never changes, for some strange reason, all of you can do this, but a great many of you have trouble with this. Sine of 72 is just a number. It's a decimal, yes?
Yeah.
So it is 5 times that decimal will get you x. Of course, a great many of you are then confuzzled by this one. 10 equals 50 over x. There you get in trouble. Because you don't want to show work. Every one of you can do this blue one, but this green one's like, oh man, I don't remember what to do. Do I divide? Do I multiply? I don't know. Because you're trying to learn some shortcut. Which I do show you. I do give you that shortcut, but not before we work it out algebraically. Because knowing a shortcut is only good if you know how to get there without the shortcut. Because if you get lost on the road when you're on the shortcut, you're in trouble. So of course what you would do with that is you multiply both sides by x. Those x's cancel. 10x equals 50. Then you divide by 10. X equals 50 divided by 10. Now once you can do that algebra, that allows you to then go back to the original question and say, hey, wait a minute. At the end of this question, I ended up doing 50 divided by 10. So why don't I just do it right here? That's how you get to earn using that shortcut. Okay? Those are the only two things you need to be able to do trig. To be able to do the math for trig. Is there more to trig? Yes. That's all you need for the math. Then we draw a little line because then you also need to remember 3, the vocabulary. And that vocabulary is, there's only 2. What's that? An eye. Excellent. How do we represent the direction that an eye looks naturally? How do I represent where my eye looks? Vertical line, horizontal line, diagonal line, where?
Horizontal.
A horizontal line. Your eye looks out there, yes? That is the base line. That's where your eye looks, horizontal. Right now, you're all sitting down, and the screen is above your eyes, isn't it? So your eyes are looking in what direction? Up. So for you guys, the screen is up here. Right? If I turn this screen off, and I look at Mitchell like this, he looks right in my eyes, yes? We are level, yes? Once I go like this, Mitchell now doesn't have anything to look at, so he looks up to the screen. So his eyes go up. Yes? What angle does that make? That right here, it makes a theta. And that is our elevation. Or inclination. Right? That's the first piece of vocab. Now, if I drop a $100 bill on the ground, where are Mitchell's eyes going to go? to the ground where there's a $100 bill. His eyes have to start flat. Ooh, Mitchell, look. I wave a $100 bill here and I drop it on the ground. What do his eyes naturally do? Look down to the $100 bill, creating another angle. What is that one? Depression or declination. How do I make those into trig? I make them a triangle. And now I can do trig. Okay. Everybody good? What angle is this right here? There's your 90. Your eye line is your hypotenuse. Everybody good? If you know those three things, you are ready for your test. Okay? Now, please remember, sometimes, like on this question right here, you need stuff from this triangle, the green triangle, to find the answer that you need for the question. Okay? So you need to be aware of that. That is why trig is powerful. You can use stuff you know to find stuff you don't know. All right? What I mean by that is as follows. If I have a triangle and I know one angle of it and I know one side of it, what does that information give me? I can use that to find all the other sides, yes? Once I have all the other sides, can I not then draw other triangles off of those sides? And then use that information to work with those triangles. Does everybody understand? Okay. Trig is used to measure in the real world, yes? Is this piece of paper the real world? No. The real world exists in north, east, south, west, up, down, left, right. All of that is very difficult to draw on paper, isn't it? So you have to be careful, right? I mean, all of you understand what I just drew here. Right? It's a house. Is that what a house looks like in real life? Of course not. Because this wall does not go flat on a piece of paper, does it? Where does it go? Up from the ground, right? And then this wall right here does not go diagonally, does it? It goes straight backwards. What angle is right here? What's the angle between the up and the ground? No. What is this angle? In reality, 90 degrees. Is it 90 degrees on my piece of paper? No. So you have to be careful with that, yes? If I draw something like this, can you do trig on that triangle? Look again. Can you do trig on that triangle? Why? Okay, I'll give you two numbers. 7, 18. Can you do trig on that triangle? No, why not? Why? No right angle. What if I drew it this way? Can you do trig on that triangle?
Yeah.
Why?
That's a right.
Because it's got a right angle. Does it look like a right angle? No, because it's drawn on 2 dimensions. Like this over here, right? You have to be aware when something is a right angle, even if you can't draw it that way. Does everybody understand? Okay. Start on page 73. Work with each other. I don't care. Yeah. In a perfect world, that would be done by 9:30. I don't think that's going to happen because number 5 is going to make you all cry, even though it shouldn't. I want to mark this tomorrow, which means testing is Thursday. I'm going to bring around your quiz because I've recorded it.